So in these, we want to think about periodic trends. So ionization energy, the periodic trend for ionization energy is that it increases as you go across and decreases as you go down. So we know that if we look at these three elements, that fluorine is the highest and to the right. So fluorine is going to have the highest. And then if we look at nitrogen and arsenic, nitrogen is in the same row and arsenic is below that, which means that we have nitrogen, then arsenic. So we go from least to greatest. So for radius is going to decrease as you go across, increase as you go down. So once you look at the trend, you can then just start to think about how do you organize these elements. So we know that the furthest one down and to the right is going to be the largest. So in this case, that would be cadmium. And we know that anything else in that row is going to be smaller than cadmium. So also in that row, we have Te, tellurium, followed by krypton, xenon, then krypton. And so we can look at those in this order. So now when we think about electron affinity is how much it is willing to essentially take in an electron. And so when we think about this, we know that there are some elements where it is positive. So in this case, the highest is the strongest desire. So electron affinity is more negative and approximately the same as you go down. So in this case, we want to find the more negative to the right and preferably a little bit more to the top. So if we look at these elements, most of them are in the same row. So we are looking for the one the furthest to the right. And so in that row, it goes indium, tin, antimony, beryllium. So beryllium has the highest electron affinity, and the least electron affinity is indium, followed by antimony, followed by tin, because so if you were to be asked to rank them, that's a B, followed by indium. And these are super close, but antimony has a slightly less electron affinity because it has a full half shell or a half-filled shell.